Recently, these two bastions of pseudoscience, Richie 5.0 and the Sleeping Warrior, have decided to accuse me of cheating on the Cavendish experiment. And obviously I take exception to that, and we'll get into it in a few minutes. But before we go there, let's have a look at the level of scientific investigation these two get themselves involved in.
We will have a look at the scientific investigations we get ourselves involved in a moment, once we have talked about what you said about cheating, parlour trick, whatever. So why did we accuse you of cheating? Or said it was a parlour trick? Because, as I was trying to tell you and FTFE, if you want to go with Newton's first law, then there has to be a force. A body at rest will remain at rest unless acted upon by a force. Your small balls were at rest. Therefore, in order for your balls to move under Newton's first law, there has to be a force. PhD Tony himself said there was no force acting on the balls. Therefore, under Newton's first law, there can be no acceleration.
No amount of evidence will ever persuade an idiot. No amount of evidence, it seems. No amount of showing you 100 or 1,000 proofs will ever get your blinded eyes to see. Oh, no amount of evidence will ever persuade an idiot. No amount of evidence, it seems.
This is why FTFE had to keep speaking over me, and why you yourself refused to answer the question about Newton's first law in Jose JG's live chat. Shout out to Jose JG. If you're not subbed, go sub. So as you can see, PhD Tony writes to Sleeping Warrior, there is no force acting on the balls in Blue Marble Science's experiment. Now again, Newton's first law tells us because your balls are at rest, they will not accelerate without a force, that they will remain at rest unless acted upon by a force.
No amount of evidence will ever persuade an idiot. No amount of evidence, it seems. No amount of showing you 100 or 1,000 proofs will ever get your blinded eyes to see. Oh, no amount of evidence will ever persuade an idiot. No amount of evidence, it seems.
Again, this is my whole point. Newton's first law no longer works in Cavendish or Einstein's version of gravity.
She explores the field of advanced experimentation in the field of aerobic bottle dropping. Let's have a look.
Okay, so we have a density tower, just a little one. Oil pretty much, and water and soap. And does have a pencil and a Nerf gun end in there. I was doing other experiments and freezing it, doing a diary in a different way. Didn't work, obviously, but worth a try, right? But yeah, this is a density tower.
Okay, so people tried to accuse me of cheating in your comment section, Blue, saying that because I used soap and water and oil, that I was trying to get it to mix. The problem with that is, my whole point is that they are not going to mix. Because they're going to be falling at the same rate, they're not going to mix. So, yeah. It's like, how can you accuse me of trying to cheat by using dish soap and that, and oil, when my whole point is that they won't mix, when people keep telling me they will mix. But if they fall at the same rate, then they're not going to mix, are they? Obviously they don't understand density either, so here's a screenshot for you. So here we can see, it says what you need to make a density column. Vegetable or sunflower oil. Tick, I have oil. Water. Tick, I had that. Food colouring, no, didn't use. And washing up liquid. Yeah, I used washing up liquid with water, which is basically the soap. And the oil. So you need that to make a density column. Yet they try to accuse me of cheating for using those things. Again, these are the silly people that do not even understand density or anything. So yeah, this is literally labelled to use these things, but they accuse me of cheating by using these things, which it actually tells you to use to make a density tower. Yeah, talk about don't know what you're talking about, bro. So here, John Rapp says, I noticed that Rachie50 has put oil in the container with water and soap. I wonder if she intentionally wanted the contents to mix. That mixture is how you make white oil. Soap is an emulsifier and allows oil to mix with water. Did Rachie intend to cheat, or did she just screw up an experiment in the postulation? Now, as I showed you, that is how you make a density tower. That is on a website that tells you how to make a density column. Obviously, you just do not understand density because it's telling you literally to use those things. I used those things. They didn't mix. So what you're saying, John Rapp, is a load of poo-poo, to be quite frank.
And see whether this mixes. So we got
Yellow and green. So we just need to remember yellow and green. If it mixes, obviously there shouldn't be yellow on the top and green. Yeah, so we'll see what happens. So let's see.
Rachie, simply dropping your density column will not cause the liquids to mix. Regardless of their density, they're going to accelerate toward the ground at exactly the same rate.
Exactly, Blue, which was my whole point in doing the drop test to begin with. I had people telling me from your side that a density tower being dropped, aka on a vomit comet or whatever, being dropped in free fall, basically will mix because there is no gravity, therefore there is no density tower. Even though they're forgetting gravity is the reason things are falling to begin with in their model, they try to tell me, a lot of them try to tell me, that the liquids will mix when you drop them. When you let them fall, when you let a density tower fall, the liquids will mix. But what did you just say? That they will not mix because they fall at the same rate, which was precisely my point. I mean, you can go on Discords and there and type in fall at the same rate and you'll probably see me there saying, oh, because people are taking the mick out of it basically, and I'm saying, well, why do you expect them to mix when they are falling at the same rate? If things fall at the same rate, then why would they mix? If one layer is above another layer is above another layer and they're all falling at the exact same rate, how would you expect one layer to get beneath another layer to mix if they're falling at the same rate? You wouldn't. But this is the problem with your side. They don't have a clue what they are talking about. And then I get different things from different people that all contradict each other. And then I'm like, well, what is it? And then I do the test, and then people are like, blah, blah, blah. You know what I mean? And it's like, no, because if they fall at the same rate, then they're not going to mix, are they? Which you just agreed with. So please go and tell your own side, because a lot of them do not understand that if things fall at the same rate, then they are not going to mix.
On the other hand, if relative density is what causes this, the order the liquids are in should reverse when the column is dropped. Let's see what happens. Here's the
No. The order should not reverse when it's dropped. Why would you think that? That's ridiculous. Like, when you drop it, they didn't change densities. The more dense didn't become less dense, so then the more dense ends up going to the top because now it's less dense. So no, that's not what would happen. And why you even think that is beyond me. But yeah, let's carry on.
column in a zero-G airplane. It mixes up because the gas shakes it a little bit as the airplane goes into 0 Gs.
Mixes up because the guy shakes it a little bit. So exactly what Sleeping Warrior has been saying then all along. See, this is the problem, isn't it? This is what people actually send me and say, oh, look, it's mixing, because they're in 0 G, and they try to tell me that basically that is the experiment and that it does mix when you let it free fall. But like you've just said yourself, they shouldn't mix because they are falling at the same rate. Like you just said yourself, the only reason that mixed was because he shook it a little, which is exactly what Sleeping Warrior says. So again, you need to tell your own side this. Well, obviously you am, but they need to see this video of yours because a lot of them do not understand this. Do you know what I mean? That's the whole reason I did this test to begin with, because they was telling me and sending me that picture on the left here, and they was saying basically, it mixes because, like, there's no gravity anymore. So therefore the density tower doesn't work, because when there's no gravity, when you're in 0 G and there's no gravity, density no longer works kind of thing. And that's why I decided to do the drop test, to prove that actually they do not mix. Like you said yourself, if they're falling at the same rate, they're not going to mix. Like you said yourself, the only reason that one mixed on the left is because he shook it. That was my whole point exactly. And they try and send me that as proof that it mixes. Well, no, it doesn't mix if they're falling at the same rate, as you agreed. And no, it doesn't mix unless you shake it, kind of thing, which is exactly what he did, which again, you admitted. So, yeah, I actually quite like this video because you're backing me up. Well done, Blue.
Not mixing. So closer.
You didn't give your column a chance. It was only in free fall for about 0.2 of a second, and you did nothing to cause it to mix. Did you think about this, or just pour some stuff in a water bottle and give it a try?
Now you're saying you didn't give it long enough. Again, if things are falling at the same rate, then it doesn't need time to make it mix. Like you said yourself, it's only because he shook it. Like you said yourself, why would you expect it to mix when they are falling at the same rate? Exactly. My point exactly. And now you're bringing up time, like time is a variable that's going to change the effects. Like, do you think over time they're not going to fall at the same rate or something? Because again, you've already agreed with me that they fall at the same rate. So if they're falling at the same rate, they're not going to mix, are they?
For the artistic portion of your experiment, the deep knee bends were good, the catches were...
Okay, so for this egg experiment, now it's a bit too long for me to record and go over it because I just haven't got time for that kind of stuff. But anyway, to basically break it down, yes, he did change the density. Are you ignoring that he changed the density of the liquid? Are you ignoring that more dense than the medium goes down and less dense than the medium rises? Do you agree or disagree with that? I actually did this egg experiment myself, obviously to validate the results and things. And I did actually calculate the density of the water on its own. I got all the masses for everything. I got the densities for everything. You know, I literally, weighed everything on scales, got the mass, got the density, got the volume, did what I needed to do. And I actually did this, and actually it was density that changed it. So even if Sleeping Warrior did have a few errors in his methodology, it doesn't mean that he was wrong, because he wasn't wrong, he was right. Like I said, I did actually repeat his experiment, and I did actually calculate the densities, doing mass divided by volume and things. So therefore I did get the density difference, and I did calculate the result, or calculate the densities and determine that the density was the reason. So yeah, none of what you say really matters about this bit, because like I said, I did it myself. Anybody can do it themselves, and they can calculate the densities and the mass and the volumes and whatever, and they can see themselves that it was a density difference that changed it, and that the egg actually became less dense than the medium and therefore rose. So kind of what you say about this is kind of irrelevant, really, isn't it? Unless you disagree that more dense than the medium goes down and less dense than the medium rises. So, yeah.
Let's see what we can do about answering Rachel's question. Where does the Cavendish force come from, you ask?
No, I didn't ask where did the Cavendish force come from. I asked, under Newton's first law again, an object at rest will remain at rest unless acted upon by a force. Your balls are at rest. They then move, which means that there has to be a force acting on it.
No amount of evidence will ever persuade an idiot. No amount of evidence, it seems. No amount of showing you 100 or 1,000 proofs will ever get your blinded eyes to see. Oh, no amount of evidence will ever persuade an idiot. No amount of evidence, it seems.
However, there is no force, especially no force of gravity, because gravity isn't a force, according to Einstein. And again, under Newton's first law, you can't have acceleration without a force. This was my whole point when I went around and around and around for 3 hours with bloody FTFE. It was not where does the force come from, it was where does the acceleration come from. Because in order to have acceleration, you need to have a force to cause that acceleration. And you don't have a force causing that acceleration, do you, Blue?
Well, it comes from that expression, from that equation we looked at earlier, Rachie. Acceleration is the gravitational constant times the magnitude of a mass divided by the square of its distance to any other mass. Let's take Cavendish. I had a 22 kilogram mass. I had a 0.8 kilogram mass. The distance between those two was 0.15 meters. And if I plug the numbers into that expression, we get an acceleration of 6.52 times 10 to the minus 8th meters per second squared. Now, taking that acceleration into Newton's second law, we find a force of minus 52.2 times 10 to the minus 9th newtons. Notice the minus sign. This force has direction. I've decided that forces acting to the left will be negative and forces acting to the right will be positive. Well, what force acting to the right? How about this one? Now let's take the 0.8 kilogram mass and do the same thing. Plug those numbers in, you get an acceleration of 2.37 times 10 to the minus 9th meters per second squared. That results in a force of 52.2 times 10 to the minus 9th newtons. Exactly what we had before. And guess what? This now satisfies Newton's third law of motion. For every action, there's an equal and opposite reaction. And here it is. Now let's do one last thing. For every...
Sorry, Blue, but you trying to calculate a force into existence where there isn't one. Well, there is one, obviously, under Newton's first law because your ball's moved. But it cannot be gravity, as gravity isn't a force. You're calculating a force right now. Let's take a look what you're calculating a force right now between the balls. Let's take a look what PhD Tony says about your ball, shall we, and about the force, shall we? PhD Tony to Sleeping Warrior. There is no force acting on the balls in Blue Marble Science's experiment. So you're calculating a force into existence and saying that force causes the acceleration. And, you know, basically, again, you're not understanding what F equals ma basically even means. As PhD Tony here says, there is no force acting on the balls in BMS's experiment. So, in Blue Marble Science experiment, there is no force acting on the balls. Yet you're trying to tell me there is a force acting on the balls. Amazing how you both contradict each other, isn't it? This is what you globers do all the time. And then you wonder why we're like gobsmacked that like you always contradict each other, and then wonder why we always call you out for it, kind of thing. Because this is what you do. You're saying there is a force between your balls. PhD Tony's saying there's not a force between your balls. You don't even know yourselves. This is the thing. You contradict yourselves all the time. And again, yes, you can do F equals ma, and therefore you've got a force, kind of thing. But you didn't have a force to cause the acceleration to begin with. This is what you don't understand. This is what FTFE didn't understand. In order to get that acceleration to times by the mass, to get the force, you need a force to cause that acceleration to begin with. You don't have a force to cause that acceleration to begin with. Even PhD Tony here is telling you there is no force acting on the balls in Blue Marble Science's experiment. No force, Blue, yet you're calculating a force. Answer that one.
No amount of evidence will ever persuade an idiot. No amount of evidence, it seems. No amount of showing you 100 or 1,000 proofs will ever get your blinded eyes to see. Oh, no amount of evidence will ever persuade an idiot. No amount of evidence, it seems.
Okay, so I was thinking of formulas and I come up with a new formula for acceleration, but the previous one was weight or force equals the density of the object minus the density of the medium times the volume times the disequilibrium rate of 9.81 meters per second, which is the fastest basically that something falls in a vacuum without any resistance, kind of thing, with the minimal effects basically. So yeah. So that's how you get the weight or the force, by doing the density of the object minus the density of the medium times the volume times the disequilibrium rate in a vacuum. So then you divide the acceleration rate, the number that gives you at the end of doing that formula, by the mass in order to get the acceleration. But there is another way to do it. However, if you don't want the force, you don't want the weight, and all you want is the acceleration, there is a simpler way. Then we can do the density of the object minus density of the medium times this equilibrium rate in a vacuum divided by density of the object, and that will again give you the acceleration rate. So as we can see from the formula for acceleration equals density of the object minus density of the medium times by the disequilibrium rate 9.81 divided by the density of the object. That is all to do with density of the object, density of the medium and disequilibrium. Absolutely nothing to do with mass, volume or gravity. In fact, it is only relative density that gives the acceleration, and this is how we prove it. So let's say the medium density and the object's density were the same, and I will even give you 9.81 as gravity for a moment to prove a point. 10 kilogram meters cubed minus 10 kilogram meters cubed equals 0 kilograms meters cubed times 9.81 equals 0 meters per second. Oh look, no acceleration. Why is that? Because there is no difference between the object's density and the medium's density. Therefore, no disequilibrium. The relative density of the two are the same, and thus the acceleration rate is 0. Again, proving it's all to do with the density of the object and the density of the medium, aka relative density or differential density, or whatever you want to call it. But basically, the relative density, so one density relative to another density. So just how left can be relative to right, it's one density relative to another density. So again, proving that it's the density of the object relative to the density of the medium that actually causes the acceleration.